Next hour or so. We're going to be talking about big data. And my first question is not to this experienced panel of experts, but to you in the audience. How many of you think you know what big data is? I've seen most of those hands. Well, just for those who may not have raised it and not really sure, I heard a really good definition. Big data is data that is so big that you can't fit it on your hard drive. You have to go someplace else to get it. And it's also, it's bigger than that. It's a concept. It's the fact that the data is in fact so big that we need extra tools, analytics, storage capacity, things to make sense of it. So big data is not just the data itself, but being able to do something with it. So what I'm going to do, at the risk of running out of time, because I've got so many experts up here, I'm just going to ask you very briefly, just give us your name, the utility that you're from, and what your exposure is to asset management and big data. Just real quick, because we've got a couple of questions to go through. So let me start here, Mike.
I'm Mike Collins, City of Harrisonburg. We're a facility about 16,000 meters. SCADA systems, CMMS system coming in new, and advanced metering, or various stages of advanced metering at this time.
Cool.
My name is Alberto Quiroz. I'm the Master Planning Manager for Suez, based headquarters in New Jersey, but operations mostly in the Northeast. And in terms of data, of course, meter data is probably the one that generates more volume in a way, but also operational and getting just the right information, knowing from our customers.
Anas Malkawi, Hampton Road Sanitation District here in the southeastern region of Virginia. We have 13 treatment plants, about 250 million gallons per day, about 500 miles of pipelines, so we don't have any data to deal with. A lot of meters, a lot of operational data, a lot of financial data, a lot of just all sorts of data to even comprehend. So.
I'm Tim Mitchell, and I'm Director of Water Resources for the City of Lynchburg, which is a small city in the middle of Virginia of about 100,000 people. And we have about 25,000 accounts. And we are at various stages of implementing our CMMS system and asset management and meter renewal replacement with advanced metering. So a lot of our data is still in the heads of a lot of our older employees, and trying to extract that before they leave is a challenge as well.
You can't fit that on a hard drive.
That's right. Yeah. Okay.
That's fragmented.
My name is Mike Stewart. I'm the director of the Portland Water Bureau. I was the chief engineer for 10 years before that and started our asset management program. I'm very fortunate to have a not so young man anymore. He's going to retire next month, much to my chagrin. Jeff Layton works for us, and I just do what he tells me I should do regarding asset management. Our utility supplies the city of Portland, which is about 450,000 people, and another 450,000 people in the metro area through wholesale contracts, and we've got lots of accounts and 3,000 miles of pipe and so on and so forth.
Well, I'm Tom Kiefer. I'm from Baltimore County, not at all to be confused with Baltimore City, which is often done. We have about 860,000 residents and similar, about 3,000 miles of pipe, including all the laterals. Currently I'm the Bureau Chief for Engineering and Construction. Prior to that, and sort of still, I'm the Bureau Chief of Utilities, which is where our asset management really started growing from. And my involvement has been mostly on the guidance level, I guess, and certainly as I've gotten busier. And we're growing organically. Our budget office and others in our administration don't quite grasp all the asset management concepts, so we're growing it with decision-making tools. And so piece by piece, we're putting it together. And our presentation will deal with some of that tomorrow, but actually some of the big data issues that we have to deal with today are problematic because of that approach, but it's also allowing us to at least do something.
My name is Elkin Hernandez. I'm with DC Water. I'm a manager for process control there. So my role is more in the automation world, you know, on sensors, instrumentation, how to gather that data and make it available so we can realize the value through different applications. I'm part of the group that is implementing and developing the strategies to make that become a reality for us and to realize that value.
Okay, guys, the first question I really want to ask you, and maybe for the benefit of those who haven't really used the big data or just your awareness, what do you think the best application that you can think of for big data? Something where the volume is large and the benefit of the analysis is great. Where do you think the sweet spot is for this big data concept? And of course, if there's no answer to this, we can all go home.
I'll give it a try. Well, I think the first one, at least from the SUEX experience, it has been the SCADA. It just leveraging all the data in the SCADA. I mean, sometimes it's on a kind of militarized zone. Only a few people can see it. So what we did is actually put it outside of the kind of militarized zone, put in an intranet. So put it in engineers' hands, actually even have access to even managers if they want to do it. So now, because on SCADA, you have data on a minute level, hourly, daily. Now, what you do with it, that's the biggest challenge. But we have seen the last 5 years how the results of doing that. Like a lot of people are actually deriving good intelligence from that data. Before, you had to go through kind of the gatekeeper, the operators. Hey, can you get me the tank levels for the last week or so, and then accessing that information was difficult. So that is kind of that was kind of the first thing we tackled.
So the SCADA was really kind of the big data, but we were all looking at those circular charts to try to figure out what was going on. But that's all you got to see was that piece. Anybody else?
Just kind of building on that a little bit, one of the things that we've done, and actually we have a very talented person, instrumentation technician that has written a lot of code, and actually a lot of our SCADA information is now available just right on our cell phones. I can pull up a ton of history on our wastewater treatment plant and all the performance measures and how it's performing now, and even the amount of air in each aeration basin. I can look at right now and see what's going on, what the plant flows are and everything. So he's built an interface to where it's enabled us to be able to see real time what's going on throughout the system, which has been a huge benefit to us.
So in other words, the big data isn't just looking at one set of data, but it's comparing different sets of data actually and commingling them.
Correct.
Okay. Down the end?
So we're finding certainly with GIS as being the way to be able to pull it all together. I mean, we have so many different cubby holes of data, and none of those cross-communicate. And so for us to be able to, and I think the term you had was this ETL, the extraction, transformation, and loading, and be able to put that and pull that together in a way that people can use and see, that's the platform where we get to see it. Now it ends up being, as I mentioned earlier, because of the way we've grown things, it's a little bit clumsy, and getting data in and getting data out and making adjustments and updating data between the databases is awkward. But as soon as we started going to the graphical interface, the willingness of people within the organization to interface with the data and check the data to see all of a sudden, did it really reflect their project, and is the project progressing in the GIS, is it showing that it's progressing the way that they know it is, and those sorts of things. And it's really increased the level of engagement, which has helped the asset management program.
Just a comment there. American Water, we have a meter data management system that is really on a GIS platform, and it's the graphics is just really a huge part of this, is to let your operations people visualize, see what's going on.
So one of the other things we've been doing that kind of my cohort here was talking about is mobile data. We use Oracle WAM, which used to be Synergen a long time ago, and that integrates pretty well with Esri GIS. And it became a problem for our field people. If you use a phone this size, you could call up, if you had to do a shutdown, one of the big deals on a shutdown is figuring out which valves you have to shut off. And sometimes your picture is too small. Well, now there's an iPad that's bigger than a standard iPad, and you can actually read it and get enough in there that you can find the shutdowns. So now all our field crews, there's 15 field crews out there digging the place up all day. They all have iPads and can pop this thing up through Wi-Fi. Pops up really quick. We're getting less mistakes. And we spent time talking to the field guys. Field guys don't like filling out forms, period. So if you can automate filling out forms, that's good. And it's even better if you spend the time talking to them and telling them, what good is this? It's not just some engineer saying, look, you can collect the data, collect it, thanks. It's showing them what it does, and you can do that on the iPad. So you can get a lot of benefit out of big data once you have it.
I mean, we found that a lot of our systems really serve certain parts of our organization. So there's not really one solution that you can say it pulls all the information together. So in an organization like ours, where we have collection systems, treatment systems, pump stations, facilities, we have a CMMS that's clunky on the linear side, but great on the vertical side. We have a GIS that's great on the linear side, clunky on the vertical side. You know, we have an ERP that's great on the financial side, but clunky on the HR side. So you have to have in my mind, the sweet spot would be the business intelligence tools that can kind of bring together different information from various systems and give it to you in a dashboard to make those decisions from.
Well, that's following on that. Going back to the original question, which one is the biggest application? Hard answer because it depends on where you're coming from. On the O&M side, I would agree with business intelligence being significant, giving a significant value. We have deployed already one dashboard tool with business intelligence. Then you have the challenges of getting people up to speed, running it, getting the max value of it, which is, deploying the tool and installing the software is the easy part. Getting value of that is part of a learning curve. We are also exploring very closely the idea of realizing value of big data when it comes to vertical assets. So going from the traditional SCADA system where you're just monitoring the status, speed, you name it, seal water, into something that can integrate the vibration monitoring and do a more comprehensive assessment of the whole asset, prediction of failures, put it in context with the process. That's a vision we have and is to be developed yet. We have seen that on the linear assets, there are more mature approaches especially for water distribution networks, where there are in the market packages that can realize value of big data by providing event management tools. So there are so many things. It's what you need and what is your what your urgent immediate needs are and what your long-term vision is.
Okay, great. I want to go back, and a couple people had mentioned, obviously, data as part of big data. What about the quality of the data? And I'm thinking more along the lines of, say, GIS. The example I always remember is the 1925 pipe that is PVC. That happens in your system, and it makes it difficult. I'm sure there was a little old guy who was actually out there molding PVC in 1925, and I just haven't found him yet. But seriously, I'm looking for, as you're going through this process, you must be aware of the data cleansing aspect of it. Do any of your tools help you kind of clean that up, or is that just a very intense manual operation?
So, like every engineer, I love data, but I run a water utility, and data costs money, and more precise data costs more money. So the level of precision that you need ought to match what the heck the use is, not because somebody can collect it. I hear that often from my staff. Well, we could collect that. Well, what decision are you going to make with it? If you can't tell me what decision you're going to make with it, you're not going to spend the money to collect it. One good example of where imprecise data is good enough, like most larger cities, you've taken over smaller cities, annex them, whatever the heck it's called in your jurisdiction, and their record keeping may not bear any resemblance to yours. So we would get into, the age frame was like 1910 to 1940. Sometimes we couldn't figure out what the pipe was because there was no data. We knew there was a line drawn on a map, so we knew where it went. So how old was it? How do we throw that into our framework? So I told them, you don't have to know that answer exactly. Go look when the subdivision was built, slap that date in there, and forget about it. Just use it. What's 10 years, plus or minus? So I think the precision and accuracy of the data ought to match what you're going to use it for, and you shouldn't be spending money on it because it costs big bucks to collect it just because you can collect it.
We have an audience request.
Here, you do.
If we're talking here about
he's got
asset
it.
management, data is key. I mean, if you can't say this is good enough, 10 years, 20 years, or the material is PVC in 1925, or ductile iron pipe in 1965. That's to me, if my focus is asset management, that's not good enough. That's not acceptable. So,
You and I would just have to disagree on that point.
I think it depends on the order of magnitude of the error. If the bulk of your data, the key data, in other words, you're using this data, for instance, to decide whether to replace a pipe or not.
Right, exactly.
And very clearly, if the pipe says it's 1925 and somehow in your analysis you deem that pipe made between 1925 and 1935 needs to be addressed, and you turn up a PVC pipe, then maybe, in my mind, what you might do in a good analytic technique would be to look at main repairs. Maybe you've actually had a main break on that pipe and you actually figured out that it is PVC, and shoot, it's not obviously not 1925. Somebody's replaced the pipe and it comes off the list. But as you're saying, if it really is a 1925 cast iron pipe, and we're thinking it's PVC, and we categorize it wrong, then that's,
So you're making decisions
Yeah.
that cost millions, tens of millions.
yeah, so it's a weighted decision, I think.
That is not good. To me, that's a waste of money.
And plus or minus 10 years on a 100-year-old pipe.
Right.
You're not making $1
Yeah,
million decisions.
yeah.
But I mean, we're talking 1925.
Yeah, but if it's your hospital district or hotel district, then you're going to want to know the criticality, and 10 years could make a difference. So it depends
Yeah,
on the
absolutely.
criticality.
But
You don't base
So-
it on the year, it's age, you base it on
Condition.
Well, yes, we can talk about vintage versus age, and, obviously there are, we've got,
Remember that your mathematical models are not one specific type of data. They're a collection of data, and I think, Dr. Sinha, I think earlier you had a classification of data, which is, this is my primary data. This is what has to be my good quality data. This is my next level of quality, and then this is my nice-to-have data. So one of the things is you have to classify, what is that data, to your point, that I need to be more precise in terms of my model?
So I don't mean to be flip, and I get your point, and I would just say that if you're in the business and you're in a big city and you're taking over older cities, the data may not be there. You must make a decision, make the best one you can. Otherwise, no model works. Now, if you're saying, if it was PVC, your example, and it was actually cast, that's a big deal. That's not a good guess. But 10 years either
10 years,
way
yeah,
in a cast
exactly.
iron pipe, you may not know this, but Portland, Oregon is really Montana. There was this thing called the Missoula Flood a couple of eons ago. And when the ice dam broke, it stripped the soil from western Montana and eastern Washington, and some of it got dumped in Portland. I have the most benign soil I can imagine. My pipe life is 150 to 200 years for cast iron. You know, so to me, 10 years, don't get worked up. But my staff they got into long-winded arguments. Oh, what data are we going to use? And blah, 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 blah. Well, look when the subdivision was built, pin the date on it, and get on with it.
I'm down here.
I just like to think of it just a little bit differently. When I think of asset management, I think of talking with my financial fella and getting prepared to have the funds to deal with the action I need to take, but that just delivers me to the project management phase. And in the project management phase, that's when I'm selecting and chartering the project. So I may be 10 years down the road planning for something and arranging the funds based on the long-range plan, but when it comes time to make the decision, then I'm into a second gear of condition analysis to decide. And I make this comparable to a car. If I bought a car and I expect to get 15 years worth of life out of it, and I don't want to, and I want to cash fund it, I want to have that money in 15 years. Okay, but in reality, when it comes time to the 15th year, am I going to walk out there and get rid of that car because that's the day I said I was going to do it? No, not telling a financial guy. He and I are putting together the fact that we need to have that money in 15 years. But when it gets down to 12 years or something like that, now I'm taking a look. If I haven't had that car anywhere but from here to the garage and back just to tune it up over those 15 years, I'm not getting rid of that asset at that point in time. So there comes an asset to me, and this is just my way of dealing with it. I have the asset management planning phase, but when I get into the project phase, I'm starting all over to validate whether or not I'm actually going to do that project. And so I'm it's a whole lot easier to hit something with a gun when you're hunting, when you're close, than when you are far away. So you make a reevaluation when you get closer. So to me, it's two steps. I'm probably not going to be working for the city of Harrisonburg in 20 years, but I want to plan for them. But somebody, when they get closer, will have to redo my planning a little bit, and I kind of think of it that way. So the type of condition assessment, where I go, and the long-term financial plannings I want to do in the asset management. But when I turn over and it gets into the arena of now I need to make the decision, I'm into a whole validation process. Obviously, the asset management process wants to get me there before I incur all the ancillary social, financial, environmental problems. That wants to get me there beforehand so that I don't get caught surprised. But I don't think you can sit here and plan exactly what's going to happen in 37 years from today.
Just add something. You're talking about a hypothetical situation, but in the real world, if you had problems, someone's going to call you. I don't think it's being an operator that maintenance, every day how many calls you get. So if the field condition is different and it's pressing with the problem, you'll hear it. That's my take.
And that probably should be incorporated in your big data, right? When the customer complains, when you've got a litany of complaints, it doesn't matter whether it's financially sound to keep the pipe. If there's enough complaining out there, that pipe's coming out. Yeah.
Go ahead.
Oh, did you go ahead? All right. One thing, when you're dealing with inherent attribute data like that, be it age or material, I mean, it can make a big difference in the decisions that you make and what to go after. So one really helpful thing to do is to carry a data flag along with that. And that is something that's like, well, it's assumed. So you're pairing the attribute with another field or flag that says, well, this came from an original record drawing, or this came from, this was assumed based on best judgment. It's usually just a single word, but it usually implies, either an original source or derived from other data or assumed because you had nothing else to go on. And then what you've got is a record set that you can say, okay, now I can begin to get an appreciation for the quality of the data that I'm making a decision on, and that can be passed along to future decision makers. So it's not just, oh my gosh, if I'm off by a year or two, it's going to be, you can say, well, it's, 1930, and then you can put assumed, and if you want a comment field that says, plus or minus 10 years,
Some data you can, there are some clear examples you can say, well, you can see 1925 or some data points you cannot actually flag. Depth, traffic, all the stuff, that changed over time, and you're not aware of those changes. You were just going to take the data as is, but again, going back to my point, you need to put an effort and invest some money to go out and make sure that the valves is where it's supposed to be, that the traffic patterns are what we have in our system. They didn't change. These things, you cannot really figure them out or find them out through desktop analysis. You have to go out and invest the money and spend the money to be able to get, a good asset management plan.
Does anybody here think that big data is going to replace the engineer, that the big data is just going to dictate every decision?
No, well, and another thing that we do is we're not looking at just the waterline asset. I mean, we're looking at the entire group of assets in a street, for example. Right now we have a big project where we're replacing the water lines in our downtown area, and we've got a water line that was installed in 1829 that's still in service, and it's perfectly fine, and we're actually leaving that water line in place. But we're looking at all the assets and making a decision about the assets as a group. The road condition, the storm system infrastructure, the sewer system infrastructure. And while we're in there digging up a very complex area, we might have 10 more years of life in the sewer line, but we're going to renew it while we're there. So we're taking advantage of that and looking at the assets as a group, not just each individual asset. So we're trying to make a more comprehensive decision. And we also have a CSO program where we've done the same type of thing. We went in, when we did separation projects in neighborhoods, we just rebuilt the neighborhood so we don't have to go back for 100 years. So we didn't just do the minimum. We went ahead and took the additional step to renew the infrastructure in that neighborhood.
All right, so let me go ahead.
Oh, no, I was going to answer your question as far as is it going to replace the
I was just going to
engineer.
re-ask my question.
Yeah, I was basically going to say, no, it's not going to replace the engineer. It's just going to change how the engineer does engineering. And what's going to happen is we should start thinking of data with the end in mind. So what are we trying to get, and what are the what's the data that's needed to actually perform for the asset to perform 50 and 100 years from now? And once we do that, we say, okay, that's the data we need. Now we got to assign kind of data quality indicators to know 50 years from now, the quality should look like this. And if we have some kind of flags, like Paul was mentioning, the data source, where did the information come from? Is it assumed? Is it accurate to what level? Is it actually surveyed? Is it subfoot? Whatever the information is, and you can kind of put some indicators. I know we have for our LIMS, lab information management system, we set up data quality indicators, and it's actually working out really good for their group. And they have a QC manager it's a really robust program there. However, on the O&M side, we do have it on the operational data on the flow and pressure and rainfall. We have reliability, how reliable is your meter data. So we have some quality indicators there, but not much on our CMMS and GIS, and that's what we're trying to develop now, with the end in mind.
And to add to the kind of replacement of the engineer, there's a quote that a plan without data, it's a nightmare. Data without a plan, data, plan without data as a dream.
Wait, let me write this
Yeah.
down, go ahead.
Plan without data is a dream. Data without a plan is a nightmare. So having tons of data and not having the person, the engineers to analyze it and to take action, it's a nightmare. You're going to have, gigabytes of data or whoever, and what action? And so data without action, it's might as well not have it. And so definitely need now how people are going to be trained to do that. And the chemical civil engineers going into the water field, and I think that's kind of where the institutions, they probably have to start thinking about it, or actually they should do it now. We're kind of late already in a way.
I'm going to go to the panel first, but I have to observe that this is a very active audience. You're making it awfully easy on these guys. This is good. Go ahead.
So it comes down to I would totally agree that the human factor is not eliminated. It's how you interact with the data that is different. Your function is going to be different. That data needs to be validated. We have a perfectly validated, high-quality historian that combines real-time data with lab entry data, all verified. Still, we have to QA/QC all reports. Try to explain to somebody, can we send this out to the regulator? No, we need to QC it. Do you trust your data? Yes, I do. But I have to QA/QC it. So the human factor is evolving, is changing. It's going to be there. Even with these futuristic event management systems, there's going to have to be a person making decisions before you can trust it. You know, it's like the self-driving car. It's going to be a well, you know?
All the way in the back.
Just to make it,
There you go.
just to be clear, how many people on the panel are engineers?
Oh, I can
If
count
you just
myself.
ask them if big data, I wonder what they're all going to say. How many people in the room are engineers?
To our credit, we answered it right, though, right?
How many people are within 5 years of retirement, so they're not too worried about it?
So just consider this. I'm an engineer, I can say.
I did want to go back to the last comment here on the panel, which is a referral to what we call machine learning, that basically the intelligence is going to get better. For example, the idea that a street is going to be opened up is something that a machine can take into account. There are various other factors that can basically be incorporated into machine decision making. So that was my context of the question.
That is correct, but it's going to be, you have to account for criticality and the impact of that event. So probably for lower impact,
You're a young
low
man, aren't
criticality,
you?
sorry? For low criticality, you're going to have self-managed systems, but for some things, you're still going to have the human check for a while.
Yeah.
Thanks.
Absolutely. I'm being facetious here. Go ahead.
So you guys are touching on a very important point. There is the trends in big data right now are mobile, cloud computing, and data is getting bigger and bigger. You're going to have almost double the data you're going to have today in 5 years. How, as our utility folks, are you, and the responsibilities of your staff are evolving just to account for managing that data? How, in your respective utilities, are you able to have your engineers or your project managers manage and keep up with that type of a data trend?
So we used to have a control group that did control instrumentation 95% of the time. Now the work is 50% IT. It's evolving. It's a huge task.
I'm from a relatively small utility. We've been in SCADA business since 1988. And as I look back over it for just a second, I would say that our folks, most of our SCADA system controls pumps, tanks, and high consequence failure assets. And I would say that those it's a pretty small group, but those group probably think they have taken care of the SCADA and handle that data that they get pretty efficiently. But I will say this, getting a grasp on something like SCADA, there was an article, I didn't really get a good grasp on it. There was an article published by a firm, I think, that was around here talking about developing a SCADA system on a level from 1 to 5, its maturity. And we're probably at a maturity 3. And what I'm trying to say here is those folks who use the SCADA to try to respond immediately, try to head off short-term problems when something looks out of kilter, those folks have been using that data pretty well. That's probably about a maturity level 3. Going to a maturity level 5 is my engineers using it for other things. That's taken a whole lot longer. It's taken those engineers a whole lot longer because there's more data, more forecasting, more predicting, more strategic decisions, okay? So I would sit here and reflecting on the development of that SCADA system over those however many years that is, the operational users grab a hold of it very quickly and make their life a whole lot better, but us strategic planners, you got to get, that's when I go look back at the article I was referencing, getting it to level 5 is getting us engineers to use it. And that is, of course, there's a lot more data, and a lot more handling of that data than just taking care of the immediate response. And that's really interesting to me looking back over that.
So we've talked a little bit about the engineer. No, I'm good. We've talked a lot about the engineering helping the machine to figure things out. How about the machine helping the man with the analytics? What are the powerful analytics that we have?
That's actually what I was going to ask, is you keep on mentioning more and more data at different times and have someone look at this other data and see how it fits into the role. Why wouldn't you just use a genetic algorithm or a neural net to give you that ratio? So it's on your historic records of where you had these issues compared to the data you had then. And then you can see, given the current condition that you mentioned now, may not be what they projected 20 years ago. But you no longer have to look at that, and it allows for faster prediction. Now, you still need an engineer to actually make the decision, but it gives you that recommendation right off the bat.
Yeah, let me just give you a quick example. We're installing a system called IOSITE. It's from Israel. It's a system that basically takes in all the inputs that you can imagine into a water plant. They used it for all their desal plants that they built in Israel, and it's now being applied to more conventional treatment. And one of the inclinations of an operator when you have a rain event, and basically the water's going to get, and the river's going to get more turbid, dirtier, and so the operator turns up that coagulant. The machine can react to the changes in the turbidity literally as they're coming into the plant. And basically the operator's tendency is to leave it on a little high just for a longer period of time, whereas the machine might be able to help you just to turn it down a little bit sooner, and still actually, again, based on the history, it's going to work.
That's the way I believe things are going. That's the direction it's pointing. I think for the water sector, it still is in infancy. It's not yet there. There's some products and packages, Israel is notable, that will provide those tools. They still have big challenges there. Interoperability is a big one. And I think it goes along with IoT and being able to implement IoT at the industrial level. It's still a challenge for everybody. That's why so many big guys are trying to push for that, or the vendors and manufacturers. It's just a matter of years until we realize the opportunity that cheap data storage and a lot of computing power give us now. You know, the algorithms were there 40 years ago. We just didn't have a way to make them, sustainable, to run them in a sustainable manner. So it's going that way. How fast and which sectors and how it's going to look, I guess, is not yet defined. And big challenge, in my opinion.
Have you stored data or have you ever used something similar to SQL Server analytical services? That has presets that allow you to build neural nets, allow you to do that sort of analysis. That's why big data is growing such a big thing in the financial sector these days. Because they have more information than they can handle. They have these tools available.
We certainly have explored a couple of tools already, okay. And done some trials and trying to get up on the learning curve. There are many tools, I tell you, and all the big players are developing their products still very quietly, I would say. The products are not open there in the market yet for the most part, but they're being developed and the investment is being made.
And I will add that those tools that you mentioned are very sophisticated, cutting edge, and I mean the water industry, it's very resistant to change because of the function that we serve and the importance of protecting the public. So for reasons, and even if they're advanced, they typically come at a premium, and can we justify that? And eventually the ratepayer was going to cover that. Whereas, I mean, Wall Street, I mean, the cost benefit of trying some cutting edge technology, the return of investment is, I mean, it's pretty short. So but definitely that's the trend. I mean, for example, at Suez we have the AquaDAP solution of having just this kind of machine learning, how to optimize pumping and storage, and kind of not going, by the way, oh, I need to keep my tanks full at 3 in the morning. Well, do you really? And so we're going that direction, but right now we only case by case when actually it costs a lot of money to do even a self-evaluation, actually a full implementation. So when the costs come down, definitely the industry is going to move forward, but I think we're still, I mean, at least 10 years from that.
And is that one of the problems, is the ability to actually do a cost-benefit analysis of the big data management process?
I mean, one thing is just resistance to change. So, and on a staffing level, and using a new solution, so that once you pass that, I mean, you have to evaluate, and you need to get comfortable, and that first step is very important, but you need to spend that money at the beginning to actually evaluate if it's a feasible solution. Now, if the payoff is high enough, you certainly will go for it.
I think also I've ran into a lot of cases, in one case in particular, in trying to get into cutting edge technology. I don't know how many of y'all have AMI metering systems, but the benefits that, for example, I tried to partner with our local electric company and try to maybe share some infrastructure, and they are now no longer reading meters. They're got fixed read every 15 minutes, can provide things to their customer. And I certainly like to do that too, but I seem to be the bait when they had their technology. For me to get on board, I would have been sort of in the beta mode. Well, yeah, we're going to do that, but we don't have this yet. I've ran into more surprising situations like that, where we're out here saying we need to do it, but then you're not only talking about getting the money to do it, but well, yeah, we're going to have that next week. We're going to have that next month. And I've been really surprised in the water industry. And particularly, I can read all kinds of articles on AMI, but AMI was I think there's I think Manassas, and if there's anybody here from Manassas would be able to speak to that, but I believe they actually partnered with their electric company, and now they're ready to, the last I heard, they're ready to pull the water meters out because of all the unproven, invested and unproven. And I got that information from my electric company in trying to partner with them. You know, if we could have built infrastructure together, looking for an opportunity there. So now I'm sitting in a utility where I like to be progressive. My electric company's farther ahead than I am, but it's just not there available for me right now, too. So it's not only the dollars, sometimes it's the technology's not here with our water industry. I'm seeing a lot of people going like that, so I'm guessing maybe I've hit a chord here that's really happening.
Yeah, that AMI area is very tricky, and there's been a lot of regulators who are pushing to get the electric and water pushed together so you piggyback. And with some of the coming technologies, that may not be the right answer. I could talk to you about that. There's a lot of super systems that are on the horizon, and
I can't tell you how many times I've heard.
My caution would be to any utility right now that's looking at AMI, wait 2 years and see where the industry is. It's going to be pretty amazing.
I'll just make one last comment. Being small like we are, though, I really have to look at my organization. Being my engineering department's about 3 plus me and the assistant superintendent, and I'm really looking at restructuring my department to be able to put people who can become who can actually focus on a lot of the problems we're having here more time than what we can dedicate to them today. And that takes a 3 or 4 year restructuring effort for me just to get the FTEs approved and do that. So that's another obstacle also.
There's a guy over here who wants to make sure he's going to get a drink after this session.
If I can figure out, I'm going to start drinking. Okay, I got the mic. David, just a real quick question. You know, it's interesting. I'm hearing everybody's responses, and one of the pieces that fascinates me is how do you define big data?
Well, I tried to do that at the beginning where we were talking about.
You threw it out, and I heard everything from GIS pipes to SCADA to
absolutely.
AMI.
All of that is all of those elements have so much data to them in order to get through it, to negotiate, to make sense of it. You not only need the storage capacity, you need the ability to display, the ability to analyze, the ability to make decisions or have the machine make a decision or help you make the decisions for you. That's what big data is.
So I just find it interesting because I think if you talk to somebody in the IT world or you talk to somebody who's dealing with real big data or where big data actually comes from, we don't even touch it. We don't even touch it in the water utility realm. I mean, even big utilities using very advanced models. I mean, we're not talking to the level of big data that's out there, and not to bust bubbles. I mean, we work with a lot of data, that's for sure. But I'm curious of where this big data concept is coming up for water utilities and how we're talking about it. And it's interesting because it's a completely different sphere. When you think about consumer data and how much is getting actually processed in other industries. So I'm finding it fascinating as we start to get into the discussion. I mean, maybe big SCADA systems, start to really push the threshold, or machine learning starts to really push the threshold. But comparing it to like your basic GIS capturing of data on your pipe assets, I just think that's data. I don't think that's big data.
No, well, that's data, but the big data decisions you're making is what pipes do you replace? What pipes do you need to put acoustic monitoring on?
Even that, I don't think touches big data.
I'll attempt to answer that. Try, at least.
Okay, I want a good conversation.
One thing we were talking about earlier is that whole, can you fit it on your personal computer? That's one definition that I heard. But in my mind, and we talked about it earlier too, it's the capacity of how much, where is it stored, and what's the capacity that it holds, and then what's the frequency of it coming in. So between those two, do you have the capacity to hold that information based on the frequency that's coming in to be able to analyze it and spit out results? And then, so if you have Amazon, for an example, that have way more data than any of us can imagine,
Google.
right? Or Google, or crowdsourcing type, web services. They have way too much data. But if you look at the IT staff that supports that and the capacity that they have to hold it and the analytical tools there to actually process the information is far more substantial than any of these utilities would have. So you got to look at our IT departments and the capacity that they have and the tools that we have. The data that we have is beyond our capability. So that, in my mind, that's the definition of big data, is what you can't handle with your resources.
So contextual to resourcing, essentially?
I would say so, yeah. Because, otherwise it would be subjective to everyone as far as what big data is.
Okay. It's just interesting because when you hear, it could be a utility with 5,000 services and they're just trying to work with their GIS. Or you're talking about 1 million plus services and they've got advanced, SCADA system.
But I bet you both of them can't handle the information that they have.
Yeah, it's just interesting to hear the terminology being applied.
And keep in mind, too, the GIS, and we've talked about it a little bit, GIS is sometimes the platform, the way that the data can be displayed. So it's just an element of other data that relates to it.
I really don't think that big data concept, or the concept of big data even exists at this point. Like you said, Amazon, Walmart, Google, all these guys, they have enormous amounts of data. The storage is very cheap, and I don't think that's an issue anymore. And as the storage becomes cheap and as the amount of data becomes larger, there are also programs and software, the Oracle Business Intelligence and all this, that can actually summarize the data and give it to you in a dashboard form.
Right, it goes to a cloud because you can't, but, well, it's not an issue, but it's because the data is now going to clouds, to places that are remote to your machines.
So I thought I would shed a little big data light on the definition of big data. Wikipedia, which is probably big data.
Reliable source.
Big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate to deal with them. Challenges include analysis, capture, data curation, search, sharing, storage, transfer, visualization, querying, updating, and information privacy.
So it is relative.
That's the right definition, Peter. What you are saying is it's not just volume. You are talking about volume. Volume doesn't mean, I mean, Amazon has more volume, but problem may not be common. You are just doing data mining. They don't predict. These guys are predicting 5 failure. That's the rocket science.
The remnants of data left
Google
behind.
does predictions.
Really should be talking about good data. I mean, I agree that it needs to be good enough, not necessarily 100%. We're lucky because we're living in a time when cloud storage exists, so that really the quantity of data that we're able to collect is not an issue. We can store it. We have capabilities for neural nets and all that. But it's really how good is that data, the quality of it. The term big data, if you actually look, Google the history of it, it's not a good thing. Big data is about the fact that the data is being collected, keeps going up exponentially, and we can't differentiate between the good data, the stale data, the completely false data. I think as utilities, we need to focus on collecting appropriate data and utilizing that as possible.
How about we do?
Well, I would call that the challenge rather than the way to discount it, because it's here to stay.
I'm not discounting, I'm just saying that the big data, collecting more data is not good.
Walter.
That makes it a complex process. You cannot take this 15 variables and all the data, great data. Right. The way it is for analysis, it's relative also. It's not all data generated needs to be stored. Like you said, not all data generated is even more cloud collecting. So choices to make.
The challenge in our industry, please disagree if you feel that way, it's not about how much data we're collecting or how much are we able to store. It's about how much of it is you can use it. Most of the data that we collect is almost dark. You don't really know what you have. Almost like there's studies that talk about 85 to 90% of the data that you have in your organization is dark data, which is really bad. You have all the data, and you talked about investing money in collecting data, but if you're not able to utilize it and convert it into meaningful information, I think to me that in our business is a bigger challenge than how much data is coming into our system. Is that something you're seeing as a challenge, a bigger challenge than the volume?
Let me go back to AMI. I mean, we now have the capacity with these new two-way systems to collect a read every hour on the hour from every meter. Does anybody look at all of that data? Heck no. They grab one read by month for reads, but when a customer has an issue, when a customer has an inquiry, they can access that data. We can access that data to discuss whatever the problem may be. We can analyze what those reads are to see if some customer, maybe every hour the water's being used, which suggests that there's a leak, and we can give them some kind of an alert. So it's not a matter of reading all the data, it's a matter of sifting through it and getting what you need.
That's the problem AMI solves, in that it has the ability to take all the data and process it and give you the information that you're looking for. But I think sometimes in our maintenance management systems, GIS, although we have all the data sitting there, we really don't know what to make of it.
And that's where the analytics have to come into play. Sunil, we're out of time? Or we can have some more time? Oh, good. Okay. We're still going strong. Yes, sir.
Piggyback on your comments. I sort of feel that I've gone through and looked at a lot of different data sets over the time, and you really don't know how good or bad it is until you start doing the analytics. Then you find out, how this data set you may have been collecting 20 years ago or even 5 years ago, all the things they were doing wrong as they assembled it. So it's really the analytics now that are going to tell you how good or bad your data is. And it's great that you have the tools to start doing the analytics and making the decisions. So that's just a comment, but I was wanting to hear, where do people think we're going to go next in terms of opportunities for using big data in your organizations? What are a couple of things you're thinking is the best business value you can get from it in the near term, in the next 1, 2, 3 years?
Hey, you can't answer this incorrectly because nobody's going to remember what you said.
To be honest with you, we're kind of taking because of that, challenge. We're taking a step back a little bit because we noticed lessons learned from our CMMS implementation. Get it out there, get people using it, and get them collecting information without the end in mind of what are we trying to capture here. And then all of a sudden we have a whole load of information or data that we can't turn it into information because it's in whole different formats and everyone fills it out a different way, no consistency. So we're taking a complete step back and we're reevaluating levels of service and risk criteria and criticality and likelihood and all those things to make sure that the information that we're going to capture is going to mean something when we want to make a decision on it. So right now at this point we're kind of taking a pause on a lot of but I guess in a way we're thinking about the business intelligence once we have the right systems in place, and we have already systems that we know they're going to stay. We have some systems that were questionable, but what do we replace it with? So business intelligence in our mind is going to be that tool that would bring that information from those different systems once we do that full evaluation.
But what you say sometimes, it's better to set the objective, decide on the analytics before the data. And the data is going to feed, and you're going to collect the data to feed that specific analytics, which is exactly what you said. Suppose I collect data as much as we can, and we have access to, and now what do we do? So going the other way around, I remember a client who wanted a specific model, and when I asked her about the data, she said, "We don't have it." That's interesting. Never heard about that before. It's more like this is the data. We want those analytics, and now we have to try to get the data to match the objective. And I thought it was actually interesting what they told me is that no, we know that's what we want to achieve. We know that tool. We trust that tool will achieve that. And now you are going to tell us, what data we need to collect. And I thought it was a very interesting. It's the first time I ever worked, under those premises, but I thought it was a very interesting approach. Exactly what you said.
You mentioned levels of service. I thought that might be a great application of exploiting the data. How do you determine, more accurately the level of services that you are providing and where there's maybe some gaps? Instrumentation of things.
My vision of AMI incorporating having that data going into our water model directly and knowing exactly what the flow is in any pipeline in the city at any given time, being able to see water age, knowing what to do when we have a break, to be able to divert the water and flow. So I guess I'd like to say, you're saying we use it for reactive needs, proactive needs, and predictive needs, right?
All right. That's where we're getting the predictive.
I mean, reactive, it sits into place until you have a need for it. Proactive, you're trying to think ahead of it. Predictive is like maintenance, how much of cleaning we should do, what we do, and all that kind of stuff. And data is important because at the end of the day, some customer calls a council member, you need to be able to say, did they have a problem or not? I don't think data is going to go away. It has to sit until used sometimes, but sometimes it's used all the time. It's a critical part of our business.
He's talking about asset management and the O&M portion of it. We're about 4 months into a CMMS implementation. Pretty expensive one at that. It's kind of interesting. I have an IT specialist in my apartment. That's one thing I'll recommend if you're in a small one. Make sure the IT person knows how to run your operations. Don't go get one in the support department from somewhere else. That's my first recommendation. But I can tell you, my IT man, he'll tell you I know more about a water system than I ever thought I would. But back to the CMMS implementation. What we're finding is that, you know, a lot of times we start this project with this is the goal in mind, like we build a tank and everything else. We're going to scope it out, and this is what we're going to need at the end, and let's get on a path to project to do that. We're finding that doesn't work in using our CMMS system. What we've kind of done is got into an agile type project where we get the end users involved, and my project manager, they're continually redefining the scope of what are you going to use it for? What are you going to use it for? What are you going to use it for? And I didn't get all the details, but right before I left, my IT specialist came back from Utah with a week seminar, and he said, oh, you ain't going to believe this. Said, we're farther along, and these people have had it for 2 or 3 years. And I'm like, couldn't be. Couldn't be. There's no way. I'm worried to death about it. We spent all this money, and I'm thinking, wow, we're going to have a ton of data. And I'm seeing my project, and I've also got another project manager. Every process we got now, running, sitting down with them, what are you going to use it for? What are you going to use it for? What are you going to use it for? Because if we let that thing go on like it was planned, we're going to end up with a system where we got a lot of big data, and I'm going to find big data as information left behind that we never used. So that's my definition of big data. But it's real interesting because now my CMMS team, we're 4 months in, and they've got the mentality that we got to sit down and redefine what we're doing rather than putting something in place that we thought. We spent probably, I can't tell you how much time planning our flow processes and everything before our consultant came in and delivered it to us. And we're finding out, boy, that was great, but that was only the beginning. So my project manager now sits down, they're just redefining the scope, drive the car a little bit, redefine the scope, drive the car a little bit. Otherwise, we're going to end up with a $500,000 system and a whole bunch of big data. And that's the reality. And that just takes away so much time from where my people need to be. And that's the dilemma of someone who operates a utility like I do.
Yeah. One
question.
Go ahead.
Has anybody given any thought to how the quality of construction inspection or the quality of construction methods or the transportation? I'm talking about buried assets, the transportation of the pipe. These are factors that can affect how the pipe functions. During that, right? So, and I feel that has a huge impact on how much life we get out of the pipe or how it performs throughout its life. Is that data collected by anybody? Is it looked at?
No.
Yeah, right.
Next question.
Yeah, the answer is no, but and this is coming up certainly in our jurisdiction, and as you go through the records, you have a couple of things. One, inspection from a municipality is rarely 100% on site, so you miss observation points. Two, as we've looked at our force main breaks, they seem to be principally due to construction error and not to anything else. I mean, that and surges are kind of the two primary elements, but you just don't have the presence to be able to capture that kind of data. And actually, you're absolutely right that the connection between those 2 points is very important, but lacking. Yeah, and I think in part of the discussions today, that whole field aspect of it and getting data from the people who are working in the field as being part of asset management plans and data seems to be a pretty significant gap. I mean, we're kind of taking it from the time we have data onward, but not.
What about new constructions? Forget about the previous record. New one, are you capturing this data? The new construction?
That's probably one of the most challenging issues.
What happens is you don't have the feedback loop to tell the people that are in the field now what's important to look for. I mean, if they follow standards, yes, but as soon as they turn their back, they go to lunch, they fill out reports, that's the piece of pipe that didn't get put in the right way, and you don't know.
Well, that's not, let me just I was called in to review some PVC pipe failures for Hawaii. It was a tough job, but somebody had to do it. And one of the things that they were able to do was to go back and identify 3 out of 12 contractors where the problems existed, and 2 out of 6 inspectors where the problem was. So yes, this data can be collected. People are hopefully getting better at it so that, you know, there was an opportunity to take corrective action. And it did have to do with poor installation, and there were forensics performed on the pipe breaks themselves to determine, more often than not, the problem was improper bedding.
Just gave me a good idea. Put that information on as-built, who the contractor was and who the inspector was. Yeah.
Assuming the data that was collected was not necessarily, was the bedding, you know, when I inspected.
No, it wasn't.
It was more of who installed it and you saw a trend.
Yes.
And who inspected it and you
Saw a trend.
And then that gave you a breadcrumb to then start looking deeper into now it's an installation problem.
Just to give an example of that poor inspection, we had a PVC failure on the Fentress line, and obviously it was poor bedding. It was actually bedded with concrete chunks underneath it, so the loading basically, you know, gave out. But then when we tried to do some analysis of what's actually causing the failure, it was actually 2 failures. And as we were doing the analysis, yeah, we said it's poor bedding. So we looked at the pictures of the construction of that pipeline, and we found a picture of the actual concrete chunks under the pipe. So the question is, who took the picture? And why didn't they say anything?
My guess would be an ex-inspector.
Well, I mean, they're probably still around. They just bounce around between different companies that it's hard to, you know, keep track of that. So the only thing we can do or try to do is, you know, put some language in our specifications and you know, provide some training and guidance for, you know, but beyond that, it's really one of the biggest challenges that as a utility we have is poor inspection.
Absolutely, and I think you have to
Oh, yeah.
invest in training of inspectors. You have to hire more inspectors because they go from location to location. Sometimes they rely on the word of the contractor. So maybe the contractor took the picture and give it to the inspector after the, you know, because they say, oh, you finished, you can call them. You finished oh yeah, I finished. So they write in the ADR that they, you know, they finished it.
Well, the bad news for Honolulu was that this problem is over a 15-year time period, and they're just little time bombs probably ready to break. And it's difficult to figure out, well, exactly where they're going to happen. So.
But isn't that what your asset management methodology is all about? You take historical information in order to predict future potential.
Right.
So now you have historical information. I have a certain set of inspectors and a certain set of contractors, and now you know where there's time bombs potentially are.
Well, the time bombs are scattered over 50 miles of pipe. That's the problem. It's just too big.
I'll add a phrase, it's a field adjustment, because something comes up which they didn't plan, they just turn the pipe and then keep going on.
Field
They
adjustment.
don't want to change the
Laziness.
That also happens. You kind of have a siphon which is not designed and, you know, it doesn't work. Hydraulic don't work.
I wanted to ask the panel before we leave, have you guys worked with any analytical companies, any big data managing type companies, and what's your experience with them? Anybody?
We're just we're demoing Tableau as one of multiples. One of them is Tableau, where like just I don't know if you're familiar with it, but it's the one that generates these pretty graphics that the New York Times has, that it can throw any statistics and actually help you essentially kind of your big spreadsheet, and generates much more kind of try to extract business intelligence off of it. And actually, so we're demoing it. We don't know if that's the solution. Also, Microsoft has a BI module that we're kind of testing, but we're not even close to actually selecting one. And I don't know if we will. Yeah.
We looked at almost all of them, and the challenge is that it takes a lot of customization, and not just customization, because it is a COTS solution, but you got to sit back and do the algorithm yourself, and that takes a lot of effort. So even if you bring an analytical tool, you got to bring the service element in there, and that's the costly piece. It's not the software that's going, the service behind it is what's going to, you're paying not just the investment initially, but you're paying the service to maintain that system, over the N years. We have no idea how long it's going to be. So that's what's keeping us from, making a decision on one of them is a service piece.
Yeah, our experience with the big data, particularly the bigger the company, the more distant they are from knowledge of the water utility business. Somebody asked, where did all this get, how did this get to the water utilities? Well, it's probably just been taken from the electric utilities, but hey, electricity is a whole lot different than water, and for the concepts to be explained, like you said, and to actually do the logic and the analytics is us. And Annie, this is paying. What do you talk about? Giving somebody your watch to have them tell you what time it is. That's what this is.
No guts, no glory. Hit it again.
No, before drinks, we have
Working
just
on
one
it.
item.
Working on it. I can't get him to work with me.
Yeah, we just need to finish one more item after this.
All right, you ready to take over here? I want to thank the panel first off. These guys did a great job.
Celine, we just need to finish one last item, the award one.
Okay, you want to do the award now?
Yeah, we can do it and then we can go and have some. Okay, guys. Yeah.
Thanks, guys. Good job.
Okay, so Matt is not here, so we can skip.
So that they won't show up in
No, that's fine. I mean, he can take.
So we do Peter, and then somebody here to take the award
Right.
for Nick,
Yeah,
for
Rick
Rick.
Nelson.
Okay.
And then
And Kelly, somebody here to get an award for Kelly?
Kelly, yeah, CDM, somebody is there from CDM Smith.
No, Brown and Caldwell. Kelly's Brown and Caldwell.
Right, Brown and Carol.
Somebody's here to get the
Yeah.
award. Okay.
Good, okay.
So we're starting with Peter.
Yeah, we're gonna start
And
with
then
Peter.
NASCO, I will, not Ted, I will call Ted.
Okay.
Okay, so that's it.
Okay. So one thing we showed you earlier today in our initiatives is we have annual awards, and related to participation in the swim center, as well as promoting the concepts of sustainable water infrastructure in the U.S. And we've also have a national award, although this year we don't have anyone for that national award. We're hoping maybe next year we would be able to get some different nominees for that. So the first award we want to give out is for the swim industry leadership. And this year's recipient, you guys got to interact with him today, is Peter Kraft. He is the asset management practice lead for Confluence Group. And he spent about 10 years working at Denver Water trying to get their asset management program up and running. And he's really been active in swim on many levels. He actually set up our first West Coast conference that we had in Denver, and was very successful. And he's also taken the lead, obviously, in the strategic planning, which we talked about today, and helping us with the overall business plan for the swim center. So Peter, would you please come up and accept the award? You have to have a picture.
Okay, thank you.
Have to hold it. Okay.
All right.
So our next award is the Swim Utility. Oh, no, Matt's not here, so we're skipping the Utility Leadership Award, but it would be Matt Stolte from the town of Blacksburg. I guess he's sick today, but he really contributes quite a bit in terms of utilities. He's been very active in swim. The next award is our Water ID Award, and this is kind of a sad award to give out. The recipient is Rick Nelson, who recently passed away. He was the Vice President and Director of Conveyance with CH2M Hill. Sad story, he battled throat cancer in 2011 and then unfortunately passed away September 1st this year. Rick was one of the founding members, and I've worked with him over the last 4 years, and he really contributed a lot, and just very sad story. He was a very nice man, very
very well respected in conveyance. And we have somebody from CH to accept that award on Rick's behalf.
Thank you very much. I will make sure Rick's family is aware of the award. For those of you that got to work with him, I'm sure you all know what a special person Rick was. He touched a lot of people's lives in a very positive way. And thank you for making the recognition.
And then our last award is related to Pipe ID, and the recipient is Kelly Durr. He's a senior associate with Brown and Caldwell. He could not be here today. He has over 40 years of experience in planning, design, and construction of water and wastewater. I know him from plenty of presentations on condition assessment, particularly for pressure mains. He's an expert in the field. And he's been with the Swim Center about from the beginning as well, for about 4 years with us, and has really contributed in terms of the Pipe ID, getting us utilities to participate, getting us data, and helping with the standards. So unfortunately, he could not be here today, but we have Paul is going to come up and accept the award.
Kelly, we have one more student, Ted. You can come here. So Ted Devoda, he is the director of NASCO. NASCO established a fellowship program for the students. So this year we are giving to Vivek. Vivek is here to receive that award. The student is working in the stormwater area, and that's really thankful to NASCO for establishing the fellowship award. So Ted, if you can.
Thank you.
Actually, this award is in honor of David McGill, who's a Virginia Tech graduate who started Avanti International, has been a long time and passed away 3 years ago. Longtime supporter of the industry. His son Daniel McGill actually took over a business. So I thank you for. We look forward to your future work. Thank you.
So that concludes. So we should be ready for drink is outside. It's a long day. So.
Great, thank you.
Yeah.